Hello. Last thing in this chapter is something you've probably seen before, and it's called scientific notation. It's easier than what we've been doing. So here's the point of it. Don't write this down. The mass of the sun is 1 something 989 and then that many zeros, kilograms. Okay, so if you've seen scientific notation before, this is the context. Some numbers, like astronomical numbers, literally, are just too big to write down, but we still need them and we still need to do math with them. So we use powers of 10 to write them down. So we use scientific notation normally for really big numbers like this, or really small numbers like that. The mass of a dust particle is 0.00 blah blah blah, some more zeros, 8 kilograms. Okay, so we just need a way to write those that's a little more convenient. Okay, so this seems more complicated than it is. In scientific notation, numbers are written as x, some number x, times 10 to a power. X has to be between 1 and 10. X can actually be 1, but it'll usually be some decimal that's between 1 and 10, and n is some integer. So power, you know how powers of 10 work. If n is a big integer, that corresponds to there being a lot of zeros, which corresponds to a big number. If n is a negative number, so like 10 to the negative 5 or whatever is 0.00041. So that makes the number tiny. And really all it does is multiplying by a power of 10 moves the decimal place back and forth. Okay, so let's see some examples. There's an example right off the bat. I'm not going to make you count all those zeros, but that's how you would really write the mass of the sun. You would not write out that giant number. You would say, okay, it's 1.989, and then with the decimal place moved over 30 times. So I guess it's 1.99, that means there are 27 zeros here. So it does give you a sense of the scale, because 10 to the 30 means, wow, that's big. You know, if it were 10 to the 100 or something, well, that would be 100 zeros. That's a lot of zeros. That's a big number, okay? So here's how you do it. And this is all I'm going to ask you to do, really, is convert and then maybe do a little multiplication and stuff. So here's how you convert 6,482 to scientific notation. We need it to be, well, we need it to be 6 point something times 10 to a power. So the first thing is to take the decimal place. Now it's an invisible decimal place, but you know it's there. And you want to move it over until you get to one of these numbers, until you get to a number between 1 and 10. So the way to do that is just to move it however many times you need to until there's just a single digit to the left of the decimal place. So it's going to be 6.482. Since you moved the decimal place 3 times, you're going to need a factor of 10 to the third. All right, so we can't just write 6.482 because that's not the same number. But if we did 6.482 times 1,000, that would be it. And 1,000 is 10 to the third. Right? That's the same thing. So multiplying by 10 to the third is exactly the same thing as moving that decimal place over 3 times. For a small number, the process is basically exactly the same. So this is 0.062. We need it to be 6 point something times 10 to the something. So you're going to move the decimal place over however many times you have to, so 2 times, to get 6.2. And then you say, okay, to compensate for that fact, though, I need to go the other way. So since I moved the decimal place twice, I need a factor of 10 to the negative 2. All right, so it's always until there's like a single non-zero digit to the left of it. It'll be 1 point something or 2 point something or whatever, 6 point something. And then the power you put with the 10 corresponds with how many times you move the decimal place. And the simplest way to think of it is if I'm dealing with a small number, then I need a 10 to a negative power. If I'm dealing with a big number, then I need 10 to be to a positive number. The smaller the number, the tinier, the more negative this will be. And the bigger the number, the bigger this one will be. Okay, now we're just going to see how to multiply and divide numbers that are already in scientific notation. Not hard. 3 times 10 to the negative 3 times 8 times 10 to the 50th. So what you don't want to do is like turn them into regular numbers and then multiply them, because this one has 50 zeros, right? Pain in the butt, but you don't need to. So you can think about these numbers as having two components. So it has the normal, like the 3 part, the number between 1 and 10, and then it has the power of 10. So since it's kind of all being multiplied, you can just multiply the 3 and the 8, and then multiply the 10 to the negative 3 and the 10 to the 50th. Like that. 3 times 8 is 24. 10 to the negative 3 times 10 to the 50th is 10 to the 47th. Right? You just add the exponents. So negative 3 plus 50 is 47, except in this case, and this won't always be the case, you have to adjust it a little bit. So this isn't really in perfect scientific notation because it's 24 and it needs to be 2.4. So that's okay. So to get it to be 2.4, we need to go one place back, which means to compensate for that, we have to add one more power of 10 to this part, right? If we want to take this decimal place 1 back, we have to compensate by making this, push it like 1 forward. Okay, so if you move the decimal place back, you need a bigger power of 10. Like that, 2.4 times 10 to the 48th. So you don't just multiply, you have to check this number. This number has to be between 1 and 10. And if you change it, you have to change the power of 10 as well. Okay, same goes for division. Let's do one. So example, 1.8 times 10 to the second over 9 times 10 to the negative 2. Now in this case, since these exponents are pretty small, you probably could just write them out and divide them, but let's do it. So same deal, you do 1.8 over 9, and then you multiply it by 10 to the 2 over 10 to the negative 2. 1.8 over 9, just use a calculator, but then 10 to the 2 over 10 to the negative 2 is going to be 10 to the 4th. Because you subtract the exponents. So 2 minus negative 2 is 2 plus 2, which is 4. And 1.8 over 9 is 0.2. Same deal though. This number needs to be between 1 and 10, or else it's not scientific notation. It all kinds of needs to be the same because the whole point here is the scale. If you have a number that's 10 to the 30th and a number that's 10 to the 29th, well, that's a different sense of scale. So we have to move the decimal place to the right, which means we need to compensate for that by taking away a power of 10. It's almost like you're multiplying this part by 10 and dividing this part by 10 so that you don't actually change the number. Okay, so it's going to be 2 times 10 cubed. There you go, which is just 2,000, which is a pretty simple number. So it's almost like we didn't need scientific notation to do this problem, but we did it anyways because that's the context we're in. Okay, that's it. So really worry mostly about converting and just knowing what we mean when we say convert this number to scientific notation. Thank you.